Welcome to the online portion of the hands-on training for the Ultimaker S5. Please make sure that you have Ultimaker Cura installed before continuing with this video. You can find Ultimaker Cura on our Canvas page under the Modules Free Software. Once you have Cura installed, you should see a screen similar to this. I want to make sure you guys have Ultimaker S5 here at the top. If you don't, you can always add a printer, Ultimaker printer, local printer, non-network printer, and then S5, and you can add. The next thing I want you to look at is the materials and the print cores. Clicking on this will expand it. You may have a different material here. I want you to change this to generic, PLA, and make sure it is a AA 0.4 print core. Do similar for the second nozzle. The Ultimakers are equipped with 2 nozzles, so you can technically do dual color prints. Next, we're going to go through some print settings. Clicking on the print settings, Cura gives 4 default profiles. I want you to make sure you are clicked on the balanced and change the resolution to fast. There are some stuff you can change here. We're going to go ahead and skip that, and we'll do a custom profile today that will have you printing well in our lab. Go ahead and click Show Custom, and a lot more settings pop up. Make sure you are on the basic selection. The first thing is the quality, which is your layer height. So with 3D printing, it is a additive manufacturing, meaning each layer is extruded plastic building up until you get your final model. At a 0.2 layer height, that is a good mix between quality and efficiency. You can go anywhere from 0.1, 0.1 to 0.3 with the printers we have. For a quicker print, you would do a 0.3. For a higher detailed print, you would do a 0.1. For today, we'll stick in the middle at 0.2. The next section is walls. So a unique feature of 3D printing is that it doesn't have to be full, like injection molding. With that, you have walls. Default is 0.8. This is based off the diameter of the nozzle, which in this case is a 0.4 millimeter nozzle, which is 2 walls. If you wanted to increase the wall thickness, you would change this number, like so, and multiples of 0.4, which will change the wall line count accordingly. If you were to change this, let's say, you'll notice this gets grayed out. Changing this does not affect the actual thickness of the wall. So make sure when you are changing the wall thickness that you are changing this number. We will keep it at 0.8 for today. That works just fine for almost all 3D prints if you did need any added strength. A maximum, I would say, would be 2.4 millimeters, which would be 6 walls. The next section is your top and bottom. So similar to walls, this is just the top and bottom surfaces of those walls. The default is 0.8. We'll keep that as is. The next section is infill. Like I mentioned with 3D printing, it doesn't have to be 100% filled. And with that, what you have to fill that space is infill. It is a mesh pattern at various percentages. In this case, it defaults 15%. I would like you to stick between 5% and 25%. Anything over 25% is a waste of time and material at that point. Next is the infill pattern. For today, I'm going to have you guys do gyroid. There are videos on YouTube where people way smarter than me go in and break down different infill types and their benefits. Gyroid is just a good mix between speed and strength. We'll keep it at 15% for today. Next thing is your printing temperature and build plate temperature. I'm going to have you increase this to 210 and keep the build plate temperature at 60. The next section is speed. You'll notice there's only one setting. We're going to enable a few more settings. So hovering over the speed section, you'll see these 3 lines and 3 dots that appear. Click on that. Well, this expands and shows all the other hidden settings. For the speed section, I'm going to have you turn on infill speed, wall speed, outer wall speed, inner wall speed, scroll down, and turn on initial layer speed. You can then close this window, and you should notice that those are all enabled. We're going to slow the print speed to 50, increase the infill speed to 60, increase the print speed to 50, the outer wall speed should be 45, the inner wall speed should be 50, and the initial layer speed should be 20. Changing these speeds won't dramatically affect your print times. If you are in a rush, the best way to get a quicker print is to change the layer height. So if you were to print something at 0.2 and it would take 4 hours, it might only take 2 hours at a 0.3 layer height. So make sure those stay as they are. Next section is travel. One of the unique things that 3D printers do is when it's traveling between different parts of the print, it will retract the filament upwards so that it doesn't string and ooze out of the nozzle. We will keep enable retraction turned on. We will turn off Z-hop when retracted, though. Next section is cooling. We only print PLA in our lab, so make sure you just keep this as is. We're going to skip support for right now. We'll go down to build plate adhesion. I want you to check on enable prime blob. Next is the build adhesion type. There are 4 options that Cura provides: skirt, brim, raft, and none. Never use none. If you're going to use none, please use skirt. Skirt is a single line extrusion around the perimeter of your print. This is a good visual indicator if your print is going to stick. It does not attach to your print in any capacity, so it doesn't actually help with build plate adhesion. It is just a good visual indicator. Next is brim. Brim does connect to your print, and it is a thin single layer extrusion that connects to the edge of your print to stop your print from warping. One of the things that can happen with 3D printing is as it's extruding the plastic wants to cool. It's coming out of a nozzle that is 210 degrees Celsius onto a build plate that is 60 degrees Celsius, and so it likes to cool. When it cools, it shrinks and can potentially curl. The brim connecting to that hopefully limits how much that will happen. Lastly, there is raft. Raft is a extrusion around the perimeter. It is multiple layers. It is a solid plastic layer by the top layer, and then your print starts on top of that, which is why it's good for small prints. For today, we'll keep it on skirt. Based off your model, large flat surfaced model or sharp corner model, you might want to enable brim. Like I mentioned, the printers do dual extrusion, and we won't be going through that today. That is what we consider a more advanced feature. So if you do have any questions when you're in the lab, make sure you ask a supervisor and we can try to help you with that. Now back to the support setting. By default, it is off. We will go ahead and check it, and you'll see a few more settings pop up. I am going to have you enable a few more settings to ease with the support removal. Hovering over the support section, the 3 lines, 3 dots, click on that. Have you scroll down until you see support pattern. Enable support pattern, support wall line count, support density. Scroll down a little bit more. Support Z distance. Again, scrolling down we want to enable support interface, enable support roof, and then we want to do support roof density. So those two. Closing that, you'll now notice those are all there. All right, so extruder 1 for support works great. Unless you want to do a multicolor support print, then you could change it to extruder 2, but you'll generally keep this as extruder 1. Support structure. Cura provides two options, normal and tree. Both are automatic. With the normal support, it is more column based, so it looks like towers. And tree looks like a tree. It has a thicker stump that then branches off to support your models. My recommendation is use tree for models that have small details and normal for more generic shapes. We'll keep it on normal for right now. Support placement. Support placement is everywhere or touching build plate. Touching build plate, so imagine you are the build plate in this instance and you are looking straight up at your print. Any overhang that needs support, that's where the support will go to. More than likely, you'll be using everywhere, and with everywhere, anywhere on your model where the software determines you need support, it'll generate support. So we'll leave it on everywhere. Support overhang angle. The steeper this angle gets, the more your print under quality will suffer. We'll keep it at 60. Next is the support pattern. There is a lot of them. I'm going to have you guys do grid. I'm going to have you guys increase the support wall line count to 1. We are going to decrease the support density to 15%. Support Z distance. So if you are having a hard time removing your prints, you could potentially increase this. This is based off of your layer height. So we're doing a layer height of 0.2. So 2 layer gap there. It's an air gap. You could increase it to 0.6 if you wanted, if you're having a hard time removing your prints. Just know the larger the gap, the worse the under quality will be. Horizontal expansion, we'll leave that as default. Make sure these are both enabled. And then for the support interface density, do 66.6 or 2/3. This is the interface layer that gives a nice mesh that should help with the undersurface quality of your prints and easier support removal. Those are your supports. So now we're going to add a print in. Cura provides a few ways to add a file to the software. You can drag it from your Explorer into here. You can use this little file icon, or you can do File, Open File. If you do not have a file that you are planning to print today, please make sure you go and get one. I highly recommend that you go to Thingiverse. It is a open source platform where people can upload various print files, and you can choose one. With your file inserted, you may notice, in my case, my guy came in extremely small. When you import a print, it doesn't always come in the right size or orientation. In this instance, this guy was probably designed in inch scale and imported into Cura, which opens things in millimeter scale. So we're going to use the scale tool over here on the left and scale my guy to 2540 or 2540%. So now he's in millimeter scale and proper. Over here is your move tool. This allows you to move your model on the build plate as you see fit. If I bring him outside the build plate, you notice he turns gray. This means he is outside the build plate and it will not slice. So make sure your model is yellow. The other thing you may notice is if I lift him up, he immediately gets dropped back down. This is because of this drop down checkbox. Generally, you will want to keep this on. In certain instances, like my guy here, you'll notice that he is floating. His front feet aren't touching. Whoever designed this model probably didn't design it to be 3D printed, so he is floating. We do not want parts floating. We'd prefer to have a solid contact on the build plate as possible. So unchecking that and clicking my blue line, I could bring it down. So now his front feet are touching. You may notice though that his back feet are unfortunately getting way cut off. We can fix this by using the rotate tool. Cura by default does 15-degree increments, which is too extreme for my guy here. So I can uncheck the snap rotation and move it in smaller degrees. Unfortunately, Cura does not provide a way to input the exact degrees in which you want it. But with enough moving, you should get a guy that looks like this. You'll notice this deep blue. This is where he's getting cut off. You also notice these red spots. The red spots are anywhere where Cura thinks that it'll need support. You may also notice he has a little bit of red in his nostril. We'll deal with that later. Clicking on the model, there is an ability to mirror your object if you ever need that. There is also a per model settings. This is an advanced feature. An example of this is if, let's say, you designed your own support, you could import both models, both the model you're printing and the support, and you could click on the support model and print it as support, so it won't print with the normal print settings. The last option is a support blocker. So, like I mentioned, we have support everywhere. And that does include if you have internal cavities, there will be support that it will generate to there. To avoid that, you can use support blockers. Clicking on the support blocker, it is a toggleable button, so do make sure you have it checked on or off. When you click on your model, it'll import this cube. You'll notice it's still on, so if you start doing it, it will just keep adding cubes. We'll toggle that off. This cube is its own entity that you can maneuver. You can also scale it and everything like that. For today, this small little piece here and that one there, in reality, that's just a small gap. The 3D printer won't even notice it, so you don't need support generating to it. I will leave this cube here so you can see how this nostril is getting blocked and how this one is not. With all your settings set up and everything like that, I do want to make sure we save this profile. So click this little save icon here. Save as a new custom profile. I highly encourage you name it something similar to this. I would consider this a normal profile, and I do put the layer height there so you can quickly identify it. And then you can click Save New Profile. I already have it, so I will go down to it here. And there is my part. All right, now that you're all set with your model, you can slice it. The slicing will depend on a few things: power of your computer, the detail of your model, the amount of polygons on it, and if you're using tree support versus normal support. When it is done slicing, this guy will take 2 hours, 47 minutes, and 41 grams of material. Those are important to note so you can plan ahead. I highly encourage that you always click this preview button. This shows what your model will look like when it's printed. you'll notice that that support cube that we put in his left nostril here stopped the support tower from printing. So it is useful. These are also the other supports for those underside parts. And you'll notice that my guy got his feet chopped off because we had him below the build plate. Over here on the right, there is a slider that you can go through and see each layer. It's kind of cool. I highly encourage you always check and confirm that everything looks right for your model. Next thing I want to point out, like I mentioned, this guy will take 2 hours, 47 minutes. This is what the top surface will look like. Let's say that this is a gift for someone. I could, and I'm not worried about too much about the quality, I could increase the layer height to 0.3. And I could decrease the infill. Let's try 5%. And we will reslice it. Now, this guy's going to only take an hour and a half and 28 grams of material. So we saved in both time and material. And you'll notice this top surface doesn't look that different. Looking inside of it, it is way more sparse, but I would still consider this a fairly strong print. Once you're happy with your model, you can click Save the Disk. Saving the disk will open up a file explorer where you can save it to your desktop, downloads, wherever you like. The Ultimakers do use a USB flash drive. If you do have a USB flash drive plugged in, it will say Save to Removable. This will save it to the removable or to the flash drive with this name over here on the left. If you wanted to rename it, there will be a little box here where you can change it to Save to Disk, where you can input the name and save it to the flash drive. Then I do encourage that when you are naming your prints that you do include the print time and amount of material, because when you come in, some of the printers might not be available. A few more things about the printers. Like I mentioned before, we only use PLA, so make sure you are buying PLA. Also, the Ultimakers use 2.85 or 3mm thick filament. Do not buy 1.75 diameter filament. It will not work with the Ultimaker printers. Make sure you're buying that 2.85 or 3mm filament. Make sure it is PLA. If you buy a PLA that is PLA silk material likes a hotter temperature, so I would encourage you go to the material section and increase the print temperature to 215 for silk. Other than that, we do not allow wood PLA, glitter PLA, or glow-in-the-dark PLA because they all have additives that can be abrasive and erode the print nozzles. So make sure you are doing PLA, PLA Plus, PLA Silk, PLA Matte. Those will all be fine. Just don't get any PLA with additives to it. Thank you for joining me for the online portion of the hands-on training for the Ultimaker printers. For the next part of the hands-on training in person, we will go through loading a file to the printer and loading filament and starting to print. When you come in, make sure you have this file saved somewhere that you can locate it, as well as I want you to save this project. To save that, go to File, Save Project. Saving the project, when you open this project file, should give you a screen similar to this with the settings you used. We'll quickly look over it, make sure it looks appropriate. Again, thank you for joining me. See you at the hands-on training.